Hello, welcome to another Houdini training session. My name is Gianvito Serra, and today we're going to be talking about heap files in Houdini and what they are actually made of. So a heap file in Houdini is simply, like in many other programs, is basically a scene file. It's a file that you use to store a Houdini scene description. Okay. It's a lot like the way how Maya has the MA files, or HSI has the SCN files, and so on and so forth. So the moment that you actually are inside of a Houdini scene and we create some objects, we can go ahead and actually go File, Save As, and simply save our heap file in wherever we actually wish. In this particular case, I'm going to just save it under a folder here next to my videos. And we're gonna call this my first heap file. Okay, and that's going to with the heap. Okay, so if we go back to that folder that we just saved, we'll notice that we have a my first heap file that was just created. And in particular, in this case, I have a heap NC extension, which stands for heap file non-commercial. Okay, there is a few slight variations of the heap file format. They don't really vary underneath the hood. It's just to tell you that this particular file was done with a non-commercial version of Houdini. There is also one, for example, for limited commercial, which is the one that they use for indie. And heap is the standard one. Okay, but they're all about the same. But a heap file is a container for many things. Although it is it's a scene description much like any other scene description, it is almost like a container of almost like a mini file system, if you will. So if we actually wanted to, we could put, for example, we could actually put these objects in a subnet by selecting them and going to this little button to create a subnet from selected. Okay, so now all of a sudden I have one node that selects both of these objects. Now if we notice, if we double click on the subnet node we just created, you will notice that here is our two objects that we had before, and you will notice that the path here also changes to show that we have actually entered inside of a subnet. Okay, and in there I have my sphere and I have my object, my tool. Okay, there is a few extra things here which I'll cover in a later session, but for now we're not going to worry about these guys. Okay, if we go up one level, if we want to, we can go back to up one level to get back outside of a subnet. We can do that by simply clicking here. Okay, and this allows us to also browse in between things, much like in Windows you can browse by clicking on folder buttons. But if we are inside, by double clicking to go inside, we can also press the U key, U as in ultra, to go up, out. You can also, when you have a node selected, press the I key to go into the node. Okay, you notice that as we travel, this actually gets populated. Okay, now what's interesting is that we can continue to also go inside of these objects. So if we wanted to go inside of the sphere object, we can double click on it, and we will see that we have actually entered a different subnet of Houdini, which actually is a bit deeper than the last subnet that we were on. And we see the path has actually expanded here. So similarly, like we did before, we can press U to go back up one level, and we can press U again to go back another level, and you see that we can keep traveling here. Okay, so really it's not too different than to think of like as if you were navigating inside of Windows. Okay, similar to Windows, we can actually even have back buttons and forward buttons here like we do in any kind of file browser. And I'm going to make this a little bigger so you can see here. So if I hit back here, I can get back to where I was before, and I can keep even hit back again, and I get back to where I was then. Okay, I can hit forward to navigate. This is just like navigating an internet browser. I can even click on the little arrow below it, or I click on it to actually see recent places that I have actually been inside of this scene. Very cool. Likewise, you can also click on here to see some of the places that you have been. So for example, we can click here to jump right inside of the sphere object, as well as we can also create bookmarks to places that we want to frequent often. So if we can add a bookmark here, for example, and while we're out here, if we wanted to get back inside of a sphere object, we can just click here and go to bookmarks and go to the sphere object. And there we go. If we wanted to, you can even right click on this and edit paths as text, just like you would also in Windows. So we can say, for example, object, and then go type subnet1, and that gets us in there. We can even type sphere object1, and that gets us in there. And likewise, we can go here, and that gets us back out to the subnet level or the object level. So we're going to switch back to graphical. So again, it's not too different than how you navigate in an operative system. Now we can even, if we want to, take a look at this scene in 3 view by just clicking right on this guy here, and we can see that we can actually navigate this scene as if it was actually inside of an actual, very much like if it was an actual outliner inside of Maya, or a file browser, just like you have inside of Windows Explorer. Likewise, we can even open a text port right here, and if you're familiar with Unix or Windows, you can even run Unix commands here to see what your actual scene file system looks like. So we can do cd obj, and we can even start browsing inside of and see what objects are in there, and start browsing inside of each one of these things. It's not something we do often, but I just want to show it to show people that a Houdini scene is really not that different from a operative system or a file system. Great. Now, because of the fact that this is a little bit like a file system, this allows us to do certain things that make us objects reference other objects using a different relative pattern. So for example, if I wanted my tube to look at my sphere using the lookat parameter, I can just drag the sphere in here, and this creates a path from the sphere object to the tube object. That is, in this particular case, a full path, the full path starting from the top. So if we go to the top, we go to object, and we go inside a subnet, you will see that we see the path all the way to sphere object right here. And now once I create this relationship, I can simply click on this guy and use it to actually force the cylinder to look at my sphere. Okay, it is very important to remember this, because this is actually a very powerful part about Houdini, the fact that you will be able to create references in between any object inside of any part of your particular heap file. Whether it is in a subnet or another subnet, it doesn't matter. You'll be able to actually have access to objects at different places. So say, for example, I want to put this sphere object in a subnet. Okay, like so. You'll notice that now when we go back to the tube object, the path has actually been updated to point to the actual subnet inside of here. So even though my sphere is inside of a subnet now, the reference is not broken. Things are still working like you would expect. Cool. We can also do, in addition to the long path that you see here, we can also do what is called relative paths. A relative path allows me to start from the point where one object is and use, instead of using this full path right here, use, for example, dot dot to say that I am actually referencing this object without knowing the full path of it. Okay, what this means is that this object, I'm going to go up one level, which is my parent. In this particular case is subnet. In this particular case is a subnet, and I'm gonna go inside of a sphere object. I'm gonna go inside of this subnet that is inside of my parent, and then look for sphere object 1. Okay. Just to make it a little more clear, I'm gonna rename this to inner. There we go. Now you can see that what I'm basically doing is going up one level to subnet 1, then going, which is what this dot dot means, then going to subnet inner, and then going to the sphere object 1. You should really try as much as possible to use relative paths. The advantage of doing this is that, say for example, one day I needed to put this into another subnet for some reason. So now I have subnet 2, and inside of that I have subnet 1. When we go in here, you will notice that my path has not changed at all, and that is because it is a relative path. It is local to this particular subfolder inside of Houdini. This is a very powerful concept because, I mean, when you apply this to, for example, finding a texture or finding an object, you know, these scenes become very portable. At any point you can grab any kind of like subnet and be able to pass it to any other scene and still expect it to work. Something that in a lot of other applications is not, we don't take for granted. Okay. Now, in addition to the paths that we can create here, which are paths that reference an object internal to the Houdini scene, we can also reference objects that are outside of the Houdini scene. Okay? To do that, what we're going to do is that we will be adding a geometry object inside of a scene. Okay, and I'm going to show you a new way to add a new object on a scene outside of a shelf. To do so, instead of actually using the shelf item, we're going to left click on the network view so that we're in focus and press the tab key, which brings the tab menu. The tab menu gives you access to every single node that is available inside of this particular context in the scene to you to use inside of your network. Okay? In this particular case, what I'm going to be doing is to go to the geometry and then pick a geometry submenu and then pick the geometry node. Okay? From there, we're giving you a dotted line of where we're asking you where to drop the node, and if you left click again, it will drop a new node inside of a network. Okay? Cool. This particular geometry node, what it does, it looks a lot like the tube object and it looks a lot like the subnet. The only difference is that you will notice the icon has a little bit of what it looks like. The icon looks a lot like the tube object icon. It is a geometry container. This particular one though looks like it has a cube with some letters on it, and I'll hide the grid to see it a little bit better. This is what is called this is just what it is, the default geometry of Houdini, the geometry that shows up when you first drop a geometry node. And if we go inside of Houdini, you will notice that this is coming from a geometry file, okay, which in this particular case is looking for a file called defgeo.bgeo, which exists in the Houdini default installation path. Okay. For this, what I'm going to do is I'm going to reference a file that I have on my hard drive. In this particular case is going to be my infinite scan, which is a free scan that you can get from the web. Okay, and then it comes. And just for the purposes of not seeing my sphere and my tube, I'm going to click on this little icon right here, which allows me to hide objects outside of this subnet. So I can say, I can show them, I can ghost them, or I can hide any objects that is outside of the subnet that I'm on. Okay, and I just want to look at my head here. Cool. So you notice that this is actually now not using a geometry that is created internally in Houdini, but it's actually referencing a file outside of Houdini. But you will notice too that the path looks like it has something that is a bit unusual, which is this $hip. Okay, I'm going to actually copy this into a note so you can see it a little bit bigger. So this is what we have on the path there. What that $hip is a environment variable inside of Houdini. $hip actually is an environment variable that maps to the location of your hip file. So if we actually middle mouse on the geometry file parameter label, you will see that now we get what looks like a full path. And I'm going to copy the path here again, which in my particular case is the location of my hip file. Or in my case, in my case, the particular location of my OBJ file. What Houdini is doing is that what Houdini does, which is great, is that you can actually replace any external part also with environment variables such as $hip. $hip actually to Houdini means the location of your actual hip file, as you see here. Okay, if I middle mouse again here, you will notice that it goes back to just being $hip. Okay. Now, you have access to many environment variables in Houdini, and you can actually even see some of the environment variables that you have in your scene by going to Edit, going to Aliases and Variables, and then clicking on the Variables tab. See? So we can see here that we have a few variables that we can use. There is $hip, which you saw me using here. There is also the name of the hip file, which you can see here, and also the name without any extension, which you can see here. You also have some other ones like the location of your users folder and also the value of pi, for example, which you can be able to use in different operations. Now, just to provide another example of how you can use environment variables, if you press tab in here next to the file sub and drop a font as in font type letter font, we get an operator which allows us to create text. And I'm going to change the little flag that you see here that is blue in this node to here so that we can see it. Okay? And you can see even here that Houdini is using a variable here which is $F. And I'm going to show you that here. What this variable is saying to the font operator is to actually create 3D text which says the word frame and then has the value of $F, which in Houdini means the value of the current frame. So what happens here is that as I actually move the slider and change my frame number, you will notice that the geometry that gets created also changes to do a different number. Very cool. Now, you can also even access environment variables from your system. So, for example, if we look for our system environment variables, so if we go to my computer, oops, and then go to properties, and we go to the environment variables, you will notice that Windows comes with multiple environment variables such as path sets, processor, your location of your temp folder, your username, and the location of Windows, etc., etc. All of these environment variables are accessible from within Windows or from within Houdini. So for example, if we wanted to put the Let me see, this one seems like it could be a good one. If we're gonna put the path text, the path extension in here, we could simply put the same word here, path extension, and there it is. It's the exact same variable that you see coming out of Windows. Okay, I'll probably take frame out. To Houdini, it simply doesn't care. It just goes and maps to whatever the variable is and creates a geometry. If I put, for example, hip name here, and you will notice that as I'm typing, Houdini is kind enough to give me auto-completion so that I know what variables I have available. And so I can do this. Nope. There is the name of my hip file that I just saved. Very cool. If I do $hip, you can see the full name of the full location of my hip file. Very cool. So that's a bit about how environment variables work in Houdini. Now, environment variables can come from many different places. They can be, you can create them here by go to aliases and variables and come here and create a new variable. For example, see my name, and I'm gonna say my name is Gianvito Serra. Okay, and then I create a new variable here. So when I come here, if I go to my name, then there is my name right here. If I wanted to add my middle name later, I can just go to aliases and variable, update my variable here to include my middle initial, and there it is, immediately gets added to the geometry. Okay, so Houdini is evaluating this at all times to making sure that variables are always resolving to the correct values. You can also define, of course, any variables inside of your system. This is normally done by people who set up the environment, the working environment at your studio or at your school. But you can also, similar to how you do in Maya, go to where your Houdini installation your documents folder is, and you should have a Houdini folder and also a Houdini env file, which you can open with Notepad. And just like the Maya one, you can come in here and use it to define variables, which you can use every time a Houdini launches in this machine. Very cool. So that concludes this particular lesson. Thank you again for watching and have a good day. We'll see you in the next one.